Alright, so this is number 8. This should be the third video that we have of these problems with the optimization. And so this one right here, we've got a closed cylinder, basically container, you know, like a can of clams or something. And it holds about the volume of about 300 pi cubic inches, which is a lot of clams. But the materials for the top and the bottom of the container, $2 per square inch. And the material around the sides or the lateral area of it would be 6 inches, $6 per square inch. We want to find the dimensions so that it costs the least, okay? Because again, we want to make a profit off this, and have everybody buying it because it's the cheapest around, and we still make money. Hee hee hee. Okay. So the first thing they want you to do is to draw a picture, label the variables, write down the constraint, optimize. So basically, write down everything you need. Well, the first thing is our image. It's just a cylinder. Okay. Hopefully everybody remembers geometry, remembers what a cylinder looks like. R and H. Okay. R, H. Volume of a cylinder, I'll put it over here. Volume of a cylinder is equal to pi r squared h. Okay. The cost of this cylinder to make it, which I will continue after this labeling it C, is $2 times 2 times pi r squared, which is the area of the bases. Okay, and there's 2 of them, so that's why it's 2 pi r squared, and then it's $2, and then we're going to add $6 for the lateral area, which is the circumference of the circle tops multiplied by the height. Okay, and so there's our cost. Okay. So again, when we simplify, it would be 4 pi r squared plus 12 pi r h. Ta-da! Okay. Now the question is, what is our constraint? Well, we can only have 300 pi inches cubed for our volume. So when we plug a 300 in for the V right here, we end up getting 300 is equal to pi squared, or r squared h. Okay. And then from there we can solve whatever we want to solve. We can solve for the r or the h. The h is going to be easier, obviously, because we don't have to deal with the square root. And so that's what we're going to do. We're going to say h is equal to 300 r squared. All right. Now using calculus to solve this problem. Okay, so now here is where the fun calculus comes into play. Ooh, I'm so excited. Okay, so now we're going to substitute this in for our h. Okay, right there, in our cost, because that's what we're trying to optimize. We're trying to get the least amount of cost. And so our cost will be equal to 4 pi r squared plus 300 times 12, which is 360 or 3600, and then it's just going to be pi over r. Okay, that's because the r is canceled out. There's an r up here, and then there's 2 down here, and they reduce. Now we take the derivative of this, so c prime would equal to 8 pi r. Plus, the derivative of this side would be a negative 3600 pi all over r squared. And now we set this equal to 0. When we set it equal to 0, we're going to try to solve it, which would get us 8 pi r is equal to 3600 pi over r squared. Multiply it onto the other side. Okay. Again, we're trying to solve for r. So we get r cubed is equal to 3600 pi all over 8 pi, which reduces down to r cubed is equal to 450. Right. Which means that r is equal to the cube root of 450. Okay. So that means that our h would be okay, so we found our r, which is part of it. Now we got to find our h, which our h would be 300 all over the cube root of 450. Okay. Which, once we start simplifying it down, blah, 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 450 squared. 450 squared. And then once we start simplifying it down, we end up finding out that this is basically as far as it can go. You could, if you wanted to, go to this right here. That's up to you. That could also be your H, but this would be our H, and that would be our R. Okay, so those would be our two dimensions of them. Okay, to optimize this cylinder that we have. So now we've got a rectangular container with a square base. Ooh, square base. And the volume is 300 inches cubed. The material for the top of the container contains 2 blah blah blah. The material for the bottom and the sides contain this much. Find the dimensions for the least cost. So the volume of this this figure, which would be a square, each side is x while the height is y. So the volume would be x squared, area of the base, times the height. Okay. The cost would be $2 times 2 of the bases plus $6 times 4 of the sides. And the sides would be x times h. Okay. So simplifying this, it gets us 4x squared plus 24xh. Okay. Our volume is equal to 300. So now let's solve for h, because that's going to be the easiest, which would get us 300 over x squared is equal to h. Okay. Now we're going to take this 300x squared and plug it in for that h and for the cost. See, a lot of this, all it really is you just, solve for one thing, substitute it into something else, solve for something else, substitute it in, find a simple derivative, and then blah 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 blah. Find where it equals 0. That's essentially what we're doing. Alright, so now when we simplify this, our cost is equal to 4x squared plus about 7,200 all over x. Take the derivative of it, gets us an 8x plus negative 7,200 all over x squared is equal to c prime. Set it equal to 0, getting us 7,200 all over x is equal to 8x. Oh, x squared underneath. That gets us, moving on, that gets us approximately, let's see. No, we'll erase this. That gets us 7,200 all over 8 is equal to x cubed, which means that x cubed is equal to about 900, which means x is equal to the cube root of 900. And it doesn't really break down into anything nice. Okay, so that's our x cubed. So now we've got to find, okay, if that's x cubed, what's h? So we can take this and plug it in there. And that would mean that h is equal to 300 all over 900 to the 1/3. Oh no, 2/3. 2/3 because we're squaring it. Right. Which, if we want to simplify it, going through, multiply the bottom by 9 to the 1/3, multiply the top by 9 to the 1/3, or, rationalize in the denominator. That simplifies down into the cube root of 900 all over 3 inches. And so that would be our dimensions. So it's about, this comes out to be about 9.65, and this comes out to be about 3.22 inches, respectively. Okay. So there would be our area, or our dimensions of this rectangular container with the square base with a volume of 300 to minimize our cost. Okay. All right, on to the last question. So the last question deals with you being a hamster breeder. Okay. And what we have here is that we're trying to make the containers so that, they can live peacefully in their little caged areas, give them enough space and everything. So, and as you see, it's your dream has come true. You wanted to be a hamster breeder, which is kind of cool, I guess. You can always, that could be kind of like, your talking point to anybody. But anyway, let's work on this. So, you've got this rectangular pens, the breeds, your furry friends, blah, 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 blah. The overall area is 60 square feet. Okay, so all the pens combined is 60 square feet. And this is what it kind of looks like down here, this red image. It's divided up into 6 pens, all of equal size, which means each one has to be how much? 10. Okay, there's got to be 10 feet in each one. The outside costs 10. The outside fence costs $10 a foot, and the inside costs $5 a foot. And so the inside, this would be an inside pen, inside, 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 and all the rest would be the outside. Okay, we want to minimize our cost. So let's identify what our some of our equations are. Well, the first one is dealing with each pen themselves. X times y, which I'm going to say the length, I'm going to say that the width of it, or the top part, is x, and then the other one's y, which means all the interior ones are also going to be y as well. That must be 10. And then all of them combined, obviously, is 60. But now let's look at everything else. How many x's will we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 x's. So, and they're all outside. So 12x plus how many y's are on the outside? 1, 2, plus 2y cost how much? The outside fencing costs $10. So all that would be multiplied by 10. Added to that would be the interior. We've got 5 y's on the inside, 5y, and their cost is 5. Okay, and that right there is your cost. So those are our two equations. So we've got xy equals 10, and we've got c is equal to 25y plus 20y plus 120x. Or simplified, 45y plus 120x is equal to c. Okay, and so those are our two equations that we're going to be focusing on. Okay, this is our constraint right here, and this is what we're trying to minimize. We're trying to get the least amount of cost. All right, so xy is equal to 10 is our constraint, and we have c is equal to 45y plus 120x. So solving for this, what are we going to solve for? We are going to solve for the y. It'd be y is equal to 10 over x. Okay, take this and plug it in for the y, getting us c is equal to 450 all over x plus 120x. Now, what do? We take the derivative. Yes, we always take the derivative because we want to optimize it. So c prime is equal to negative 450 all over x squared plus 120. Okay, set it equal to 0. Move that to the other side. Got us 450 all over x squared is equal to 120. That gets us x squared is equal to 450 over 120. Reduce, 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 reduce. Ends up getting us approximately, we can take something else out of here. We can take a 3 out. We can take a 3 out of there, which turns this into a 4 and 15. And now we take the square root of 15 over 4, which would mean that our x is equal to the square root 15 all over 2. Okay. So the length of all the sides on the x side would be square root 5 over 2, or square root 15 over 2. And now we take that and then we plug it into our y, or plug it in, yes, we plug this x into there, which gets us our y is equal to 10 over 1 times 2 over the square root of 15. Right. And I'm just simplifying here. Rationalize the denominator because, you know, we can. That gets us a 20 over 15 times square root 15, which can be reduced even further to, what is that, 4 over 3? 4 square root 15 all over 3. That is our y. So our inside ones will be 4 root 15 over 3, and our outside, or our y's, these lengths right here would be 4 root 15 over 3, each one of those. And then our lengths would be root 15 over 2. And these are measured in feet. So there's our dimensions. Okay. And now the cost. How much will this cost us? We would go C is equal to 45 times 4 root 15 all over 3 plus 120 times root 15 all over 2. And that gets us approximately how much it would be, which would be about 120 root 15 dollars, which comes up to just under $465. $464.76. So for you to start your hamster breeding company, you're going to spend $464.76 on just the fencing. But it's worth it because you're going to be breeding little hamsters and it's going to be so cute. All right. Hopefully this helped with the optimization in this calculus class. Okay? Fun, fun, fun.